Welcome back to DemystifySci. I'm Shiloh.
I'm Anastasia.
This is the podcast where we search for the theories and ideas that are going to change the world. And at the heart of that project is the search for making sense of fundamental physics, quantum physics, relativity, cosmic physics. We're always looking for ways to make better sense of how the physical universe works. And so today we're back with part 2 of a conversation with James Ellias from the Inductica YouTube channel. In part 1, we basically get on the same page about this problem at the heart of physics, that there are no physical material objects underpinning the mathematics. Fields don't qualify. Bent space-time doesn't qualify. What is actually happening down there to give rise to light, magnetism, electricity, all of these invisible phenomena?
And in the first part of the conversation, we went through what it would look like to have a theory that actually is capable of explaining all of these things. In the second part of the conversation, we go through the specifics of the theories that James thinks are capable of actually carrying this weight for the world. And many of these theories all circle around this notion of the elastic ether. There's a very powerful community of people that are starting to come together to propose a renaissance of these older theories that were abandoned about 120 years ago. And in part, this conversation is not just about the specifics of how these theories work, but also a conversation about what it would take from like a psychological, social perspective to move the needle on contemporary physics, which seems to be perfectly content to work without mediators and seems very deeply suspicious of this word, ether.
I think you guys are going to love it. Remember, the only way this happens is by support from listeners like you. So if you want to make sure we can keep making better and better conversations, get on site and actually meet with people like in today's conversation, please consider checking out our Patreon page over at patreon.com/DemystifySci. Make sure that we don't have to sell any garbage that we don't care about. We're never going to be selling boner paying draft pills or whatever in order to fund this project, which is about trying to understand how the world works. And that's what we want to put all of our attention into. A couple other ways you could support the project if you are adverse to Patreon for any reason. One is you could pick up one of our cool, what would you call them?
Outfits.
Yeah. Pick up an outfit, yeah. We're moving into the fashion world.
It doesn't qualify as an outfit if we don't sell pants. We have to sell pants.
We should sell bodysuits. Look out for the upcoming line of bodysuits in the new year. Maybe like a spring clothing line or something. For now, you can grab a t-shirt. These are our designs. Nastia and I have made them ourselves. We did not stitch the fabric, but there's a couple new ones. We have a new Gothian Spectrum t-shirt that I'm super proud of. Check it out. You could also support the project by picking up our new music album.
We're actually on the Oregon coast right now because part of what we've been doing is we've been filming music videos for the record. And so we spent all day today filming for the 3rd music video that we're putting out. And anything that you put towards this project, whether it's buying a sweater or joining the Patreon or buying a record, what it really does is it feeds back into everything that we do. Because we are people that are not just scientists, we are not just philosophers, we are not just musicians, writers, artists, we are all of these things. And so when we say, hey, come over and join the Patreon or get a hoodie, we're not really talking about the specific exchange of material goods. We're saying, hey, we promise to keep bringing you really cool stuff. And so, I don't know, pick up a record maybe.
Maybe somebody else you know loves vinyl records this holiday season and they would enjoy Secretary of Nature's first album. You can check it out. We're going to play a little excerpt of it as we move into this conversation with James Ellias about the fundamental mediators of invisible phenomena in the physical universe.
You're going to love it. See you next time. Okay, so before we get into the plenum, and before we get into all of these models, and before we really dive into what will be the back half of this conversation, which is the specifics of what such a model can look like, I want to make sure that we've wrapped on the point where we started, which is like, why does there have to be a medium, and why are forces insufficient to describe the language of this. And something that I've been kind of holding on to for this entire conversation is I'm like, the central equation of physics is F equals ma in
Okay.
some ways, right? Like this is like when you open up the Principia, like so much of it is centered around getting this equation and then also getting the gravitational equation. And then general relativity comes out of the equivalence between inertial mass and gravitational mass. And so like these equations are fundamentally at the heart of everything. And the way that people interpret them is that the force is the thing that is primary. And that's what's crazy, because there's a central feature, which is that force is equal to mass times acceleration. And the way that people read these theories is they say that like, oh, okay, a force, when it acts on some mass, will produce this amount of acceleration. And so it allows us to put the force first and foremost. But I think that what we can really see from that equation is the fact we can easily reverse the implications of it, which is to say that a mass that is accelerating is the thing that has to produce the force. And that's the piece that's like missing when we talk about forces as being fundamental, because the most fundamental equation of physics says that like forces come from somewhere.
Yeah. So in other words, because F equals ma is so central, it gives the impression that forces are central. And they can't possibly be, because a force implies something producing the force, and it, of course, implies something being forced, receiving the force. So you can't, so they can't be fundamental. The fundamentals are the entities acting on one another.
Exactly.
A wave is another good example of this, right? Because a wave is an action, right? Like a stadium wave is people doing something, right?
Yes.
A water wave is water molecules moving in a particular concerted, coordinated fashion.
Yes.
And it's very strange how, just like the force, the wave is this standalone noun in fundamental physics.
Yeah. I mean, and so long as we just think of it as this disembodied action, we will be closed off to whatever powers we would get if we understood the medium and started playing with its properties in order to get results. And I have no idea what technology that will lead to, but if we understand the nature of the medium and then mess with its properties, it's gonna produce wonders. We already know how this works. When you understand the atoms that are actually combining and recombining to make chemicals, once you understand them, you produce wonders. You can produce all kinds of new materials. Once you break those atoms, it produces an untold amount of energy. Like this is what's waiting for us. Something amazing like this, if we understand the nature of the medium. And
I would also go.
That's why we need the concept. Is because you can't have actions without an entity. And, oh, well, okay, fine, but that's just philosophy. Well, but if you understand the nature of the entity, then you can control it. And that's what gives mankind power.
Power is awesome. I think that sanity is awesome too. I think that having material explanations for physical phenomena actually reinforces a more empowering outlook on reality, which is that things are understandable.
Yes.
And I can understand them. And then, yes, I gain power by being able to manipulate physical reality in order to accomplish things like putting a roof over my head or building atomic power or whatever it is. There's downstream abstract second, third order effects of that. But fundamentally, being able to think straight is valuable on its own, right? And I think this is one of the things that really drew me to Ayn Rand too. We were talking about this before the podcast, right? It's like this idea that like, no, wait a second. Like, I can understand what's happening. I can understand what's happening in my life with respect to what I'm doing and the actions I'm taking towards the future that I want to see happen. And reality is pretty straightforward and understandable, and there's consequences for the actions that I take, and physical reality is no different, honestly.
Yeah.
And so I think that there's something very disempowering about, climbing to the top of some Ivy League institution and sitting across the chair from one of your heroes. Sounds like I've like done this or something, but and sitting there and just having your jaw on the floor because you expected this person was going to have a sane answer for some of the most gripping physics questions that you had, and then realizing like, oh man, this is a really unreal, disempowering approach to understanding reality.
Yeah.
I just think there's a spiritual element to this in
Yes.
some sense. I don't know a
Yes.
better word for it. Like Nastia talked about psychological. I think there's actually some real benefit from approaching physics in this manner, in this
Yeah.
material approach.
Yeah. I agree. I don't when I guess I'd use that same word too, although I myself I don't believe in mysticism. I mean, this is why I like the demystification. Although you guys have started to look into the mystical side of things, and I don't subscribe to any of that. But I still believe that like mankind has a soul. He has a
Sounds real mystical to me,
it's
James.
yeah, but it's not. It's a natural phenomena. The soul it's your personage, and we don't understand the way that matter gives rise to this personage, this soul. But that doesn't mean it's a mystical phenomena. It's a natural phenomena. And I don't know the nature of it, but we can observe it in our own minds.
We can deal with this over dinner.
That's right. Yeah, this will be a different. Yeah, this is a different topic for sure. But so I agree. I on some level I agree with the word spiritual, depending on what you mean by that. And I think this is more than just physics, because I think no matter what side you're on in the political whole situation, I think what we see in politics is massive lying, massive disregard for the truth on both sides.
People voting against their interests, like it's terrible, right?
Yeah. And again, like not to specifically talk about any particular issue, the core of our problems is because of a loss in confidence of rationality.
There you go.
The reason for that, in part, is because is because of physics. Is because when we have physical theories that where people say, well, when someone says, I don't really care about what's really going on as long as we get the right results, what does that sound like? That's the attitude of both sides when they're lying, or it doesn't matter what side it is. When someone is lying, what are they saying? They're saying, I don't care if this thing I'm saying politically is really true or not. It matters if it gets the result I want. But how do you know you're getting the right result unless you understand the truth of it? We have to reinstall the truth as the center of our efforts. We have to reestablish the primacy of existence over consciousness. Consciousness must identify existence and act in accordance with it. It's not that existence is this, namby-pamby, gelatinous thing that just conforms to whatever you feel like. No, it is what it is. And if you don't understand it, it crushes you. Like that's the world we live in. But if you understand the way that it is, the way it really is, then you can exploit it and gain power. And that's the human experience right there. And we're losing.
And if you don't, by the way, somebody else is going to. And that's scary too, right? Because
someone else can gain that power, and then they'll come and crush you. I don't think that's something we have to worry about. I think right now everyone's
maybe not in terms of physics.
I think everyone's losing the ability to really put to put existence first. I think I'm not really worried about external enemies. I think we're all losing. We're all losing the ability. Our culture is losing the ability to think about reality objectively.
That's kind of exactly what I'm saying, though. And I think this is the Ayn Rand's anti-mysticism rant, is that if you just accept the mystic chant, then anything goes.
Yes.
Whatever somebody wants to tell you, those people are the problem. If we just get rid of them, like the mystical argument is fundamentally you can't understand. You just have to trust me.
Yes.
That's why we named this show Demystify Sci originally. It was very much in the spirit of that tradition, because we were looking at physics, right? And so when we're looking at some of the more third, fourth order abstract levels of reality, we don't mean to mystify them. We just find them fascinating, and people's approaches to studying them fascinating.
Well, I think that there's a deep wonder that inherently arises when you start to think about life. Like you said something interesting about the fact of, existence trumps consciousness, or like the physicality of the world trumps consciousness. And I'm like, I'm not. The more that I study it, the more that I find them to be intertwined like this, where it's like the universe seems to conspire to produce consciousness in a way that feels important to it, where it's like the physical objects conspire to produce systems that can think. And in sufficiently ideal circumstances, the systems that can think turn into us. And then we are probably, I think it's probably safe to say that we're the most empowered of the beings in the sense that we have all these capacities.
And we change the material surroundings as a result of it. That's the feedback loop of it all, is that by making intelligent choices or, goal-oriented actions, you can modulate existence.
And like there's all these really cool theories about the way that life and living systems work against the gradient of entropy. And so the reason that the universe doesn't just inevitably cool into just uniform heat death landscape is because there's constantly systems that are preventing that from happening, which produce order, which then gradually becomes distributed and dissipated into the universe, and then somewhere else is created back into order. And it's just like, I think that these two things operate together.
But the nature of existence has primacy. Nature, to be commanded, must be obeyed. Consciousness can only manipulate nature by obeying its laws. So it's still nature that has primacy.
Say that again?
Yeah. So nature, to be commanded, must be obeyed. So when consciousness controls existence, it does so only by conforming to the laws of existence.
Existence is just material reality in this sense, right?
Yeah.
I mean, you definitely can't get in the way of material reality, right? You can't just
you can only, and like
that bus will mow you down.
Part of what mysticism means to me is the belief that you can turn water into wine, for example. Well, what's wrong with that? Maybe you just rearrange the protons, neutrons, electrons, wine. Yeah, you could do that, but now you're not talking about mysticism. You're talking about a scientific process by which you could actually produce the result. When Jesus in that story turned water into wine, the idea was that he violated the laws of existence. They didn't know about protons, neutrons, and electrons. They could not conceive of a natural process by which water could be turned into wine. Their idea is that it just magically happened. It just happened for some reason. Another example, ghosts. When we think about ghosts, imagine if someone was really scientifically dedicated to understanding ghosts, and they go into a haunted house.
I met a few of them,
and they catch you. Okay, so let's say they actually. I think they're probably full of crap, but let's say they succeeded at all of this, and they caught one, and they studied it, and they realized, oh wow, it's made of xenon, and then they do an MRI on someone's head, and they realize, oh wait, this xenon is present in the human brain when they live, and then when they die, the xenon. I'm making all this up, by the way, but my point is what if there was a natural process that gave rise to ghosts? Then it wouldn't be mysticism anymore. It would be science. It would just be the nature of man.
But what
when
if it wasn't
someone talks
material?
about ghosts, they don't mean that. They mean something that violates the laws of physics, something that has no laws.
Okay, so hold on.
So that's the difference is not the specific claims. The difference is the mindset. Is it a reality that functions according to a particular nature, or is it just something that magically is the way it is for no reason? That's the difference.
I think I agree with 99% of that.
Okay.
I just think also that there's a very enlightenment-centered way of seeing the world through the lens of pure materialism, which is, I think, what you're talking about, which is the fact that mechanism and materialism.
I do believe in consciousness, but yeah.
Okay, and so when you say that you believe in consciousness, what does that mean?
So here's what I specifically mean. I believe consciousness exists, and I think it's
so it's like an object.
It's no, because it's non-material. It's not. But
didn't
material.
we use existence for material just now?
Yes.
So you mean consciousness happens?
Doesn't just consciousness exists?
It happens.
Though. It happens. It exists. Yeah, I'm not.
Well, hold on.
We can't use the word exist for material reality and for consciousness.
No, but both exist because they are. Well, existence just means it is.
No. I think that material. I think it would be more. I think it would be more philosophically rigorous to use the word existence for material reality in this conversation and use is or happens or occurs for abstractions that are relational in nature.
I don't think consciousness is an abstraction, though. I think it really
It's relational, though, right?
exists.
Okay,
Is it
so things that,
relational?
but hold on, let's
I haven't
define.
thought too much about this, but I'll just tell you why I think consciousness really exists.
Can we define the word exist?
Yeah. He just said
Is that it is.
What is, but exists is,
You
what is it?
can't break it
What is
down.
is?
We can't break that down any further.
I think you can just.
I don't think so. I think like things that exist are. There's
No,
nothing
so
more to it. It's just that they are.
Okay, well, what about this? Like things that
Uh-huh.
exist
Uh-huh.
have size and location in space. That is
Consciousness doesn't, though.
okay, but
Right,
that's
right.
and so the things that occur don't have to have location. Ideas don't have to have location, but things are the only things that can exist. Like you can have an idea that's real, you can have a thing that's real, but if we border our philosophy to say that there's a difference between ideas and objects, which is the foundation of physics. This is the whole thing of demystifying physics, is to say that like the field is an idea, the thing that is causing the field is the object. There's a difference between things and concepts about objects and ideas. And so if we say that things with location are the only things that can exist, and concepts are the dynamic relationship between things that exist, then all of a sudden we have an ontology that allows us to actually take apart fundamental physics and say, look, you violated a fundamental precept of philosophy, which is that the field is an idea, therefore it cannot exist.
Yeah, fields occur, or they happen, or you can even say a field is evident. But if you want to make, like, you just made a really beautiful speech about existence being primary, and I agree in the sense that material reality has to be negotiated with on its own terms. But then we have to confine the word existence to material reality, which is defined by these bodies having locations in reality that are objectively defined with respect to their location, with respect to every other body in the universe.
I'll just give you my broad views on all these things that have been brought up. So I think the physical exists, and by that I mean it is, and then the mental also is. It exists, and here's my reason. And I don't think the mental is physical, and here's my reason for thinking that. Okay, is because think about a cat. Okay, think about that cat. Okay, your mental image of this cat exists. How do you know it exists? Because you're experiencing it. It is. It has just as much evidence for its existence as anything physical.
It literally doesn't, though.
Yeah, it doesn't.
It doesn't exist physically,
right?
But it exists. You can see it you can't see it, but you can experience it. So you know
I would just say it happens. Yeah, I just think
maybe
that there's value in restricting the word existence.
Consciousness might be an action. I haven't thought about this that much, but all I can say for sure is it's a thing that is. The conscious experience is they are.
Definitely is.
Yeah, and
but it doesn't have a location.
And it doesn't have a location, and it's not physical.
Yeah.
Now someone might say, "Oh, but the neurons in your head are doing a thing, and that's why the cat there." Okay, yeah, fine. Maybe that's
Which
true.
Ones? Like when?
Which ones when? But let's say we figured all of that out. Yeah. Let's say we figured it all out. It still wouldn't be a cat. It would be neurons moving in a certain way. There's no cat inside your skull.
Yeah.
The cat exists as an image of a cat, and that's the mental. So the mental really exists.
Okay, so the cat's still an object. Like it's still a body. It's just an imaginary one. Like leprechauns don't exist, but I can imagine one. So
yeah, your idea of a leprechaun exists, even though the leprechaun
it's an imaginary object, right?
Yeah, and the imagining really exists.
I don't think imaginary things exist. I mean, I don't think leprechauns exist.
He's saying the imagining.
The conscious experience
occurs.
Exists as a conscious or occurs. Okay. Yeah, again, I'm not sure about
hold on. Hold on. Let's pause this. Pause this. Because I think that the reason that we're even arguing about this in the first place is because I think that like philosophy a functional philosophy for one place has to also be a philosophy that is applicable in all places. Like there
Yes.
has to be some parity and some parsimony here. Okay. So when we look at fundamental physics, we are making a very clear distinction. We are saying the field, okay, maybe I can ask this. Do you think that the field exists?
Yes.
Okay.
And I don't think it's just an abstraction.
Okay. All right. Let's.
Yeah.
Okay. What do you mean by that?
I think the field is an abstract. Okay, the field is an abstraction, but but that abstraction identifies something real.
Okay, but what
It identifies the fact that at each location, a certain kind of force could happen.
Okay, but does that make what is in this case, like if we're talking about like a physical realism, and we're saying, okay, what is primary here? Like it seems like the entire conversation we've had until this point is to say that, okay, the field is an abstract representation of a thing.
Yes.
Okay.
The thing exists.
And the thing is the action that could happen at that location.
No,
now,
that,
let me
no,
go.
no, no,
Okay,
no, no,
but,
no,
but
no,
I think I'm gonna address your concern by saying the next sentence.
Okay, finish.
So the abstraction identifies the action that could happen at that location. Now, actions are always actions of some entity. So there's an entity at that location with particular properties, and we don't know these properties. We don't even really know that much about the entity. So we don't know much about the ether. We know that it's there, and we don't know what its properties are, but we know it has them. Why? Because these properties can be altered in such a way that make it act differently. We experience these properties through the fields, that is, through the actions. And so because they act differently, we know that their properties are now different. What are the properties? I don't know. We got to figure that out. But we know they're there. And that's why we need a vocabulary of property, action, entity. And that's what allows us to conduct a process of reasoning of this kind. And with this kind of reasoning, we can drill deeper into the ether and discover its secrets. That's like my mission with my book, basically.
Yeah, I think we're basically on the same page.
Okay, I'm glad we got to that.
I mean,
yes,
I guess the one thing I would suggest.
I would still argue about this for the next 2 hours.
We can argue about it forever. I'm not going to I don't need to convince you of this, but I would just suggest that the way that you made your presentation made it sound like the entities were primary, and you used the verb existence. They exist to describe the entities. If you extend that verb to the other pieces of the puzzle, it doesn't clarify anything. That's all I'm going to leave it at. Like there's a lot of verbs that are synonymous with is that you could use for things that are not primary in your model, which you termed entities and existence. And you used that for the first half of your presentation.
No, sorry. It was entities and idea and properties. Exactly. So entities
but the properties exist, but they
existence. He said existence was primary. He made this speech that was very.
And that's what I'm trying to say is that like what is the ingredient of difference between an entity and a property? And I'm assuming that you have an answer.
Yes, a property is part of the entity's identity. It's part of what the entity is.
But is it also relational in the sense that like a group of entities? Because I mean, like every entity is the sum of smaller pieces, and so the property of the entity is the like emergence of how all of its subunits come together to produce it. This is kind of Aristotelian in a sense, right?
Yes, yeah. I mean, I'm on board with I agree with all of Aristotle's fundamentals. So so the entities have a nature, an identity. They have a what it is, and the what it is its properties. And the properties also exist, but they do not exist apart from the entity itself. They are part of the entity. They are part of what it is to be that entity.
I come from a material science background. This is what I did my PhD in, and that's what we mean when we say materials is entities, essentially, and they have properties that result from really the behavior of their subunits as they relate to one another. And you can pick apart why the entity or material has the properties that it does, but at the end of the day, you're still talking about why the materials act out the magic that they act out.
Well, it's not magic. It's because they are the way they are. But yes, Yeah, and you don't, by the way, you don't need to identify the constituents, those smaller pieces, and how they act on each other. You don't, and how they relate to one another. You don't have to do that to know that the entity is the way that it is. You're allowed to just say it is that way. Now, you got to ask further questions to dig deeper and get those powers, but you don't have to in order to know this entity has a certain nature and it acts this way as a result of that nature.
Yeah, like the metal's conductive, or
you're allowed to just say the metal
metal's,
conducts.
yeah, sure.
Then,
it's
then
malleable.
tomorrow you look into why, but
It's
today
stiff.
you just use that fact.
Right
yeah.
on.
Yeah.
Yeah, maybe we should flip over and start looking at some of the approaches that you've come across towards solving this, for most of us, obvious problem in fundamental physics. I'd just be kind of curious, what's some of your favorite ideas that you've seen?
So, I mean, because of my method, I would say I don't really have favorites. I have a whole set of hypotheses that I'm willing to entertain because there is evidence for them. Right. And so, Chantal Roth, who you had on the program, she has an elastic theory of the ether, and I think there's a lot of evidence for that. Something that I would want to clarify, though, and you guys got into this with her actually, which is, you asked her, do you think it's literally an elastic solid? Right? You asked her that question. And my view on that is that it isn't literally an elastic solid. We're using the word elastic solid as an analogy.
Mm-hmm.
All we know for sure, let's actually go back to what I said before. Let me explain this from the ground up. We're aware of these fields. The fields are an abstraction of action. But it's not just an abstraction of action. The entity has a particular property. The different parts of the ether have this particular property that affect its capacity for action at each location. The property at each location also causes it to change the properties of the parts of the ether that are next to it. And the way that property at one location affects the property at another location is analogous to the way the parts of an elastic solid influence the properties of neighboring locations. It's like that. So that's the nature of the analogy. It's very important to say it's an analogy. It's not literally a solid. Because look around. We're not encased in a solid, right? It's saying that and what I really like about this is that what I like about her hypothesis is that it explains all of the different physical phenomena in terms of a perturbation of this solid. We can see that matter behaves like a wave. We can see that electromagnetic effects, including light, behave like a wave. We can see gravitation behave as a wave, or more accurately, some kind of property that makes its way through a medium, that propagates through a medium. So
which is fundamentally elastic in nature. I think that the word elastic maybe didn't even get defined well enough in that, but it's some sort of reversible deformation, and the result is that you can transmit impulse between objects that are in contact through displacement, essentially.
But do we literally mean elastic means it deforms, then reforms?
Yeah.
Is it literally doing that? Are its parts changing their locations and then restoring their locations? Maybe, but I don't know if that's the underlying nature of it. Maybe some of the phenomena have that nature. Maybe now Donald Chang, for example, who also has his own theory of electromagnetism, from my understanding, I haven't read his work thoroughly yet, but from my understanding, he explains electromagnetism. He explains some of the fields as a displacement of some kind of entity, one kind of entity in the ether. So maybe some of these properties I'm talking about, perhaps the electromagnetic properties, they are a displacement, but then other properties are a different, other phenomena like matter is a different property of the medium making its way through the medium. So what we need is some kind of master theory that integrates all of the different expressions of the medium that we're aware of. What are these? Gravity, matter, electromagnetism. These are different expressions of the medium. These are different things the medium is doing different properties within the medium. So if we can understand a set of properties that gives rise to all of these phenomena, and then if we're able to make inferences that prove that that is indeed the set of properties that this medium has, then we discover something new.
This is why I was talking about earlier that I was a little allergic to the word ether because of its fluidic connotations, because I think what you said about the different parts perhaps having different structural functions and stuff is an insight from biology that I see being really true to the natural world, is that this restructuring of different parts of the cell leads to different functions. And this is also something I swear every few weeks I swear off of ever making another analogy the rest of my life.
Yeah.
It seems like a good idea every time I get started, where I'm just like, okay, so it's kind of like this. And then, freaking 15, 20 minutes later, I'm just like, why did I do this?
Yeah. If you avoid analogies and force yourself to describe it in clear terms, you get very far. And this is why I'm focused on the broad physical categories. Is you notice what I didn't use any analogies there. I said there's an entity at each location. It has properties. The properties give rise to the way it acts. There's no analogies there. I didn't call it an elastic medium or an elastic solid. I could do that, and then I'd sort of be making references to these facts, but we don't have to do that. If we use the right vocabulary, we can identify these facts exactly, and we can do so while being completely clear about what we know and what we don't know. We know there's a property there. We know there's an entity with that property. We know the entity is doing actions, specific actions. But that's about all we know at this point. We still need to know what exactly that property is. So by using a properly broad word, you're able to identify exactly what you know and refuse to accidentally imply some stuff that you don't actually know.
Overgeneralize, perhaps, over-universalize some feature.
Overgeneralize isn't quite the right word. It's just like, if you call it an elastic solid, then you're saying something you don't know to be true. You don't literally know if it's a solid. Chantel knows all of this, by the way.
Yeah.
Okay, well, a question that I have, which is, okay, so we're trying to figure out the different possible models for the substance, for the material that is responsible for the transmission of all of these phenomena. Light, electricity, magnetism, gravity, and then all of the sub-phenomena of that. But like, where does matter or mass?
I use it interchangeably, but yeah, mass.
Okay.
Yeah.
Great. And then probably like other things like charge. I think that those are probably the main 6.
Yes.
Okay. And so you have a stable of these theories that you've been looking into. And we've talked to Chantal, whose theory is elastic. And you're saying something that's very interesting to me right now, which is
it's not just elastic, by the way. It's isotropic homogeneous elastic solid.
Can you put that into regular English as opposed to nerd speak?
Well, she's just saying that there's a solid, more or less uniform block of this stuff with regularly spaced subunits, and the displacement of the subunits is responsible for everything. And
nice.
I think there are elements that I look at when I'm like, oh, this atom is vibrating. Like the atom does seem kind of elastic, because everything else I know, like I got a bunch of drums in the other room. They're elastic. That's why they vibrate. Like it makes a lot of sense to me in some sense. Strings, all the musical things we love are elastic and vibrate. But I think it might not. I think it might not be quite as simple as this nice gridded network that's implied by this isotropic homogeneous elastic solid.
Okay, so then my question is it something about the elasticity that you're taking, you're opposed to, or is it, because Shiloh's point is that it might not be as uniform as that, which, okay, and you're saying something that we can't understand if it's a reversible deformation of the substance?
Yeah, so it's a completely reasonable hypothesis to say there are these parts. When the parts change position, that causes them to exert a influence on other things that also cause them to change their position, and then the deformation propagates through the ether, through the medium. That's a completely reasonable hypothesis. But until through some process of inference you're able to prove that that's the case, all of the other hypotheses are also on the table. So one of the things I'm concerned with is describing what we know for sure, and that is that there is a property at each location which then influences that same property at neighboring locations.
Okay, and so, when you
and all models that are consistent with that very general formulation are still on the table as far as I'm concerned.
Okay, and so when
Yeah.
you say property, is that equivalent to there is a force exerted by some object at every location?
No, because there might be properties that are different from just forces. Forces are actions. They're the way one object acts on another. But here's something to think about. When we talk about force, we're talking about something that masses do to one another, right? And masses themselves are some kind of wave in the ether.
Do you mean entities?
I mean entities with mass are specific kinds of waves in the ether, and these waves exert forces. These wave structures exert forces on one another.
Okay.
And so when we say the word force, we're referring to this macroscopic phenomena. We cannot categorically be talking about the thing that each bit of the ether does to each other thing. Even if these little bits of the ether are causing each other to move like this, and these waves really are deformations, you wouldn't call that force, because force is a emergent action of the things that the ether is doing.
I can see philosophically where you're going, and I understand
So
philosophically why you're saying. Do you follow?
I'm trying to just be clear on what the word force means.
Like, I
Or
think
properties. Properties, is it just a measurable thing? Is a property just something
it's
that's
a
measurable?
what it is. Whether you measure it
It's
or
a
not.
qualifier?
Like right now, we can only measure the electric field and the magnetic field.
But
we know
properties
there's
can
a
be
what-
inferred as well.
But we know there's a what it is that the ether has that's causing those fields. And it's there whether we can measure it or not.
James is making he's making a parallel claim to the one that we make about the nature of mass for subatomic particles, where you and I always talk about this in context of particle physics experiments, where it's like mass is reported in electron volts. And that's a little bit tricky because like the electron volt is not really like a kilogram mass. It has to do with like electrical influence.
Yeah.
And so on some level, it kind of doesn't make sense to talk about mass on a subatomic level because it appears to be that the only thing that has true mass is it's like
Atoms.
true mass begins with atoms.
I'm not really. I don't think I'm saying.
You're not saying that. What I'm
I
saying
know.
is that like when Shiloh and I talk about mass, we say this, and you're saying the same thing by parallelism about forces, where you're like forces can only be between masses, and if we're talking about the thing that is below the level of the ether, it does not have mass because mass is a super lunar realm principle. If we're gonna be
Don't do that. Don't do that.
It's a thing that results from the things the ether parts are doing to one another. Therefore, it cannot be a property of the ether parts themselves.
Okay.
But we can
Which
still
is really
call
interesting,
it
by the way.
you can still grasp those properties by analogy, though. But you have to remember
it does bring
it's
up a
just
really
an analogy.
a really important point, which is
Yeah.
like we're gonna need a new set of language to deal with the subunits behaviors, because extending by analogy some of our familiar atomic scale terms is going to be confusing as all hell.
Yes. And I guess we'll have a conversation about that some other time. Yeah, because that's a whole subject matter. Yeah, and it's a very important one.
Why do we not have the ability to say that what they're doing is a force? Like, why do we bound forces as being an emergent property of the ether as opposed to being something that could happen all the way down?
Because when we talk about forces, I believe in like empirical sciences. It's not that forces are this concept and then that comes first and then we observe instances of it. I think we observe this and then we call that a force. So when we're using the word force, that's what we're talking about. And this is made of a bunch of ether or some kind of moving perturbation of the ether. And this part, all of this thing's parts are made of such perturbations. And when they do this, that's a force. So when we talk about forces, we're talking about the things that those macro entities are doing to one another. Now, if you zoom in and you look at the actual micro entities that make this up, maybe that consists of a bunch of deformations of the parts. The parts are acting on one another to change each other's locations. But that thing that they're doing to change one another's location can't be called force, because force is a macro result of such things. Force means this. And so you shouldn't call it force on that level.
Why wouldn't you think that the
else.
entities are doing, like the subunit entities are doing that to each other, though?
Doing
displacement processes.
Well, that's Chantel's view, is that these entities boil down to like displacements.
She has like this. I wish I had a better word than isotropic and homogeneous, but she has this grid structure.
Jello, bro.
Connected,
it's Jello.
of like interconnected. Oh, she has a Jello thing, right? But like, yeah, why? That's one way of viewing it. But you could also just have subunits that are constructing the cup you held up in the cell phone pocket computer thing. They're all made out of atoms, and the atoms could be made out of subunits too. Like, it doesn't all
they are made of subunits like electrons, protons, neutrons, and each of those subunits is a wave of the medium.
Well, the wave isn't an entity, right?
But
the wave is something that the subunits are doing, right?
This is a subtle in my broad physical categories. An entity is anything that acts and can be acted upon. And a wave, even though it is indeed just constituted of the actions of a bunch of individual entities, the whole process itself is an entity. Why? Because it acts on other entities in a certain way, and its properties can be changed when it is acted upon. It is what I call a formal entity. What I mean by this is that it's an entity whose properties are determined not by its matter, not by the stuff it's made out of, but by the relationships between its parts.
Hold on a second.
Yeah.
Can't let you get away with that. It's not defined by the stuff that it's made out of. It's defined by the relationship between its parts.
Yes.
Sound like you're saying two things that are the exact same, but you're saying that one is not true and the other one is true. Because you're saying it's not defined by its parts.
We started off with the parts and the physical existence being primary, but now you're saying that the actions are primary.
But it's not that they're primary. It's just that for this thing, the way it acts is primarily determined by the relationships between its parts. Let me give a simple everyday example: a human being. I think it's something like,
not so simple.
Well, okay, but like it's something you're acquainted with every day, right?
Familiar.
And you're familiar with, yeah. So like, I think it's something like every 8 years, all your atoms get flushed away, and you're completely made of completely new atoms. So the thing that makes you is not the material.
Yeah,
it's the relationships between the parts. Those are maintained, and that's why the organism continues to have the properties it has. Even though the matter is being sloughed off, flushed away, whatever, the form is maintained. The relationship between the parts are maintained. And so the human being is legitimately an entity. The human being acts as a unit. When I decide to do something, the whole body acts in accordance with that decision. And so, like, it really is right to call me an entity, even though I'm made out of all these different cells that are doing their own thing. Why? Because all the cells are acting in concert to produce a unified whole that truly acts as a result of the whole, not just a result of the parts and their nature. And in like form, like these wave phenomena, like an electron, it clearly has its own properties. It's not merely the waving of the ether, and you say, oh, well, forget about the whole electron. It's just the parts, whatever they might be, and the way they're waving. Yeah, those parts of the ether and their particular way of waving, that's important. We got to drill into that. But we can't forget that the electron as a whole is also an entity. It acts in a certain way according to its nature as a whole. Why? Because these ether parts are acting in such a way in concert so as to constitute that whole. And so this is my concept of a formal entity.
Pardon the interruption, but I have to ask you for a favor. This is a project that is supported exclusively by listeners. We do not have advertisements. We do not have sponsors. We are not selling you digital beds and supplements of questionable provenance. We simply ask that you come over to patreon.com/DemystifySci and sign up to support us for as little as 75 cents a week. In return, you get to join our weekly Sunday hangout, and you get to live with the warm feeling of satisfaction of having supported something that you want to see more of in the world. We'll see you at patreon.com/DemystifySci.
I really like that example of the humans, but I think in some sense it's why we call ourselves human beings and not human bodies.
Mhm.
Because our body is that entity that will respond to displacement pressures. Like if I step in front of a bus, the body will be rearranged.
Mhm.
Um, but the being is what persists over time. And I think there is something about atoms, I would imagine, that is being like as well, in that the subunits might be swapped out over time and it persists in its form. So I think there is something really profound about that. But at the same time, the concept of body, which is the one that I prefer to entity, is static in conception, and that it doesn't require any sorts of motion to be conceived of. Like I can conceive of a table without moving it around at all. It's just a statically conceived entity.
You might be able to conceive of it, but I think the fact of the matter is that it constitutes a wave in the ether, and it might in fact be moving with this table here is almost certainly moving with respect to the ether. So these wave structures are moving along through the ether, and some bits of the ether are being shown into the entity and others are being shown out of the entity, but the structure, so it's constantly swapping out the matter, but the form persists.
Yeah, I won't belabor it. I just think that the scale and context is really important. If I want to do a kinematics equation about this table and sliding a block across it, I don't really have to think about the subunits of the table.
That's right.
Right.
Yeah.
And so it might be the same.
But that's why we need to think of the macro table as a whole entity, is because at the macro level, it does obey these simple Newtonian laws. So you don't want to, you need a view that captures the macro level, the Newtonian level, and then the micro level when you realize, oh, it's just a bunch of individual ether bits doing something.
Yeah.
You need
My
both.
suspicion would be that that at every scale of existence, there's a context in which you can approach it as a macro scale, static body, and if you zoom in more closely, you will find that there's quite a bit of dynamics at play in terms of arranging the subunits into the macro scale entity that you're dealing with in your simplified kinematic equation.
The point that I want to wrap this onto
Please.
is like, I'm not totally sure how to talk about displacement without talking about subunits of some substance exerting forces upon one another. And so maybe we can zoom this out a little bit and establish some of the fundamental principles that we think are absolutely necessary for an ether, and like what sort of things a model has to satisfy. And then we can get down into the details of the language that we'd use to talk about it. Because I feel like
that was a minor point, really, where I'm like, oh, you shouldn't call that forces. I think
there's no minor points here, James.
Well, there are more important points to focus on right now. So yeah, let's do it.
Yeah.
So what is a good ether? What are the qualities of an ether
Theory.
An ether theory. What would it do?
What does it need to have? What does it need to satisfy?
Ultimately, it needs to. Ultimately, a good ether theory will need to make predictions that reproduce all known physical phenomena. And it would need to do so by postulating properties of the medium, and we would need to see how the properties of that medium, how the actions of the medium follow from those properties.
Hold on. So say that again. So we have
That's a tall order.
Make predictions that satisfy all phenomena.
Yeah.
And we have that properties of the medium produce the phenomena.
Yeah.
And then what was the last one?
I mean, those were the two I said so far.
Oh, I thought that you corrected yourself about the properties of the medium.
The
causing the
properties of the
actions.
medium needs to be clear how the properties of the medium give rise to the actions that constitute the physical phenomena we see.
Okay.
Yeah. And so one example of this would be the following. This is a simple example. It needs to do stuff like a good model needs to have features like this one. One hypothesis that's being entertained is that gravitation is caused by matter sucking in ether. So if matter is indeed sucking in the ether, then that's going to influence the ether medium in a certain way, and it will cause waves in the medium to change their course based on the fact that the medium itself is moving. And that would account for gravitational forces, because if, say, the Earth is really just lots and lots of little waves in the ether, and the ether is getting sucked into the sun, then the Earth, as it proceeds forward through the medium, will turn into the sun because the medium itself is moving into the sun. And so this is a small example of the kind of integration we need between the different aspects of the theory. Like, only we need to get every single part of the we need to integrate all physical phenomena under this.
And this is why you were studying the Navier-Stokes stuff.
Yeah.
I see.
Yeah, I mean, because I'm specifically looking into the possibility. This is just one more hypothesis I'm looking at. The hypothesis that there's an ether, and the parts of the ether can have more or less of a particular electromagnetic fluid, and the parts of this fluid act on one another in order to move each other around, and the moving around of this fluid constitutes electromagnetic phenomena. So specifically, the vector potential A would be the velocity of this fluid through the medium, and phi would be the pressure of this fluid in the medium. And notice that the medium in this hypothesis is separate from the fluid. There's a medium, there's the ether, and then the parts of the ether pass this fluid around. And then maybe
With like little channels between them, or
we don't need to hypothesize but like we don't need to answer that question in order to just form the hypothesis that maybe this is how it works, that it's passing around these bits of this electromagnetic substance, and so that would account for the electromagnetic part, and then maybe the relationships between the actual ether cells accounts for the gravitational part. When they say that, gravity bends space, well, what if it's really bending the ether? Really, what if it's changing the relationships between the actual ether cells? And that in turn influences the way that the fluid is transferred from one cell to the other. And that would explain why why gravitational effects influence electromagnetic effects, because it's changing the way the fluid is passed around. This is just a hypothesis, but this is the kind of integration between the parts that
like
good
this.
hypotheses will have.
Mm-hmm.
It seems like almost like a network model. Like if the cells are, I mean, in some sense, could the cells just be the atoms, and they have these conduits?
You mean like atoms like carbon and nitrogen and stuff?
Sure.
Well, in this hypothesis, the cells would not be the atoms. The cells would be the ether, and then some kind of action of these cells would constitute the protons, neutrons, and electrons that constitute atoms. So atoms would be huge in comparison to these cells under this hypothesis.
How many different ether theories have you come across? Like, how many would you say are actually named theories that you have explored to some depth and cataloged their specifics? Face.
I don't know. It's
ballpark. Like
ballpark?
I've ordered like 1, 10, 100, 1,000,
like 5, depending on how you'd count them. Because a lot of them that come across my desk or my email, really, they presuppose something that just doesn't make any sense. A lot of times, so I've come across a lot, but there's a very small number that have any real possibility of being true.
Okay.
And then further, it's hard to kind of count these, because a lot of times these hypotheses, they'll explain part of what's going on. So the flowing ether hypothesis of gravitation, that counts as one, but it doesn't explain the nature of electromagnetism. It doesn't explain the nature of matter waves. Then there's this fluid hypothesis of electromagnetism, but it doesn't explain matter waves, although it has a little bit of something to say about matter waves, incidentally, but it doesn't fully explain them. And now what Chantel's trying to do is she's trying to come up with a master hypothesis, something that really integrates all of them. And I would say Chantel is unique in this. Chantel's not entirely unique in this regard, but there's other theories that I've come across, and some of the people who have sent me this and maybe are watching right now. Sorry, I haven't read it. Sorry, I just don't have time. There's too many. Maybe yours is fantastic, but there's just so many. So I don't know. You're gonna have to give me a one-liner to convince me if you really want me to read yours. But
that's actually really good generalizable advice. I would just say that to anybody listening. If you're one of the people that are sending us emails, just if you can just make it one sentence, I guarantee you, if it's a badass one sentence, I will respond. If you write a book, I'm probably not even gonna have time. It might be the most brilliant book ever, but
well, I'll read the book if I'm convinced by the ones, if the one sentence makes it on my radar, but there's just too many possibilities right now.
We actually had a guy reach out to us in one of our best conversations on this, Adam K. He was basically like, I wrote a book and this is what the book says. It's about the hydrodynamic quantum analogy.
And I was like, can you just tell me in a sentence? And he did.
And we had him on the podcast.
Yeah,
it works.
Yeah. Something I'll say though about all these hypotheses, I don't think this is the main thing we should be focused on right now, actually, because I think it's great. This is one of the steps, and I think Chantal might be brilliant enough to come up with this, but at least for me, and probably for most people, what you really need to do first is get really clear on the nature of all the physical phenomena that mankind is aware of so far. Because I know I'm not clear on all of them yet. And I kind of doubt anyone is. Now, Chantel, maybe. I don't, but what she's done is it puts so many pieces together that I'm willing to keep listening to her, because maybe she does understand it all. That's number one. And then number two, so maybe she has all of the pieces to actually put together. That's number one. Number two, even if she doesn't, I think she's very rational. In my own epistemic judgment, she has an excellent epistemology. She's really good at being objective and not just having her own little pet theory that she defends no matter what. She's very scientific. So that's kind of why I give her so much time. And so even if she's wrong, I think she's providing an example of what we should be looking for in the future. Okay, but all of that aside, before we put too much time into hypotheses, it's really important that we understand the nature, we understand the physics that's understood so far, because I think a lot of it, in the way most of us hold it, it's just a bunch of equations, and we don't understand the nature of those equations. And what kind of understanding do we need? We need to understand, for example, here's the minimum. What is the divergence? It's the amount of outflowiness of each point in the field. You got to understand what's curl. It's the amount of swirliness of the field at each location. You need to so that kind of understanding, you need to have it for every single physical equation that mankind understands. And only then do you have a chance of putting all the pieces together, because before that, you don't even understand the pieces. So, that's the real work that has to happen first. And I'm not done with it.
Well, that extends into every space of physics, is giving actual physical context to the variables in the equations.
Yeah.
And that was kind of my earlier attack on Max Planck too, was that this equation has no physical relevance, actually.
Yeah.
It's based on one experiment and extended to all of physical reality, but there's no justification for that.
And was his quasi justification that it just seemed to work, that it put the pieces together really well? Was that his quasi-justification?
He actually, in his autobiography, basically is like, I put it together and then I spent the rest of my life trying to figure out what it meant physically. He's like, it
Yeah.
worked, but I didn't know what it meant. Is that what you got from the?
You're talking about the quantum of action, but I think that
it's a
with
different thing.
with the like the universe with his treatment of Kirchhoff's law, I think that he just hoped it would prove out to be true, and yeah, I don't think that he had a physical correspondence for it. It was not based on he just sort of wanted it to be universally true. And
Yeah. So so, some of these theories we have are philosophically flawed. So like, I mean, both quantum and relativity, like their basics are flawed, right? So what needs to happen is there needs to be a massive rehabilitation of these theories. So before anything like what Chantal is doing, trying to do is possible, you need to understand the nature, like what these theories are actually saying. You need to strip them of their irrationalities, and you need to understand, but they're not useless. They're like, they get the right predictions. They must be doing something right. So how do you strip them of the wrong parts? And I'm excited to see if Chantal already kind of understands that. She might, and then she might solve it. But frankly, I kind of doubt it. But I'm rooting for her. And again, even if it doesn't work out, she's still going to teach us a lot along the way. And she knows all of this. That's what makes her so objective, is she's just got a great way of approaching this scientifically. But I suspect that she'll just be one step along this path. And the biggest step is to understand all of the background. And that's part of what my channel's doing, is trying to reinduce all of this, find what the evidence was to begin with. And so that what that means is a stripped theory of general relativity, stripped of the idea that, space is bending or whatever, strip it of all hypotheses and just give a description. Then from that description, infer what the entity's properties are that lie behind them. And we won't be able to do that so long as we have the flawed theories we have right now that presuppose some false things.
I think this is why we're obsessed with, like, what does this word mass mean? Or, what, like, most people would think that a lot of these variables have consistently applied to definitions. They really don't, is the thing. Like, the word mass is not used consistently, actually.
Over history,
the
or
word temperature,
in the modern day?
maybe a better one is temperature. Temperature is a really weird concept, right? It's not actually consistently applied. What does temperature mean, right?
I think in the modern day it's pretty well understood, but you would be right to say that its definition has changed over the centuries.
Well,
Shiloh's about to blow your mind, man.
Okay.
Yeah, well, let me, like, for instance, I was talking, one of the early conversations we had on the podcast, I'll give you two examples. One of the early conversations we had on the podcast was with Nikki Fox, who's the director of the Parker Solar Probe. So they're flying this little satellite out to the sun. And she's like, yeah, we're flying this spaceship into the corona of the sun. It's like millions of degrees, man. And we're like, whoa, that's crazy that your spaceship can take millions of degrees. Like, that would melt every single metal that I'm aware of. And she's like, well, there's only, it's only getting hit with one particle every 20 minutes or something like that. So it's really cold there, actually. So it's really cold, but it's millions of degrees. Okay, I'll give you one more example.
Well, but you can
I'll give you one more example.
Okay, yeah.
So in this formulation that I've been studying in Planck's derivation of Kirchhoff's law, he basically provides you a map.
Can you tell people what Kirchhoff's law is?
Yeah, it's not the circuit one, I presume.
Kirchhoff's law is the assertion that any cavity which is at thermal equilibrium with an object inside of it will have radiation which is black and normal and follows this black body curve. Planck's derivation of this gives a formulation that allows you, from the intensity of light, to tell the temperature, essentially, and from the given frequency and the intensity, you can tell the temperature.
I think that there's a lot of people listening who have no idea what we're on about. It's like things that are hot have a certain spectral fingerprint, which means that they have a radiation intensity at various wavelengths, and you can determine the temperature of an object on the basis of its peak intensity of radiation at a given wavelength. And so every single object, according to Kirchhoff's law, that has this black radiation, if you know what its peak radiation spectrum intensity is, then you can derive the temperature of the object.
The problem is that everybody knows that the temperature that you get won't be the actual temperature of the object necessarily, unless it's a perfect black body. Then it will be.
Okay.
But so then what do you have in that equation if you calculate the temperature? What is that? Well, you might call it an effective temperature, but what is it? It's nothing. It's still a T in that equation. So you either get rid of Boltzmann's constant in the equation and you have a material-specific Boltzmann constant that scales so you actually end up with the right temperature of the object, or the concept of temperature falls apart. And there's so many of these fundamental variables in physics, and I think mass is one of them too, which we played around with earlier, but temperature is another one, where the meaning of the concept is really context-dependent, unfortunately. And if we want to have these be substantial, universalizable concepts, if we want temperature to mean the same thing all the time, we have to really reconsider how it emerges in these equations and what we're actually basing those conclusions on.
Yeah.
I hope that makes some sense.
That makes perfect sense. And it comports with part of my own theory of the scientific method, which is that when you learn new things, that influences almost everything else. You have to integrate all of your knowledge. You have to see some of the facts in light of the other facts, or you have to see every fact in the light of basically every other fact.
Context, yeah.
All in that context. And part of what you need to do is you need to change what the words mean, because your old meaning of the words don't work anymore. So, I mean, heat was one of them. Heat used to be just a measure of like how hot something is, and that was totally fine before everything was known.
I think we could keep that. That's a different story.
Well, no, but
we'd have to change some other things.
No, well, that's not the modern definition of heat now,
right.
and I think the modern definition is fine. Heat is thermal energy that's transferred from one object to the other, and now we use the concept of thermal energy, the internal energy U, like for the actual internal motion of the parts, and heat is that motion as it is transferred through contact, and then temperature, as I understand it, although it sounds like you're pointing out some legitimate questions here, it sounds like temperature then came to refer to the average kinetic energy of the parts. And these concepts had to change as more was learned in order to account for the full context. So that's a key part of the scientific method. And, I mean, I was just watching a video from the Dialect YouTube channel. Have you guys watched that? Fantastic fantastic physics YouTube channel. One example of changing a concept is, and this was from a video from Dialect, is that if you want to maintain a certain generalization, that the center of mass of any set of bodies will always remain constant, then what that means is you have to assign mass to photons. You have to assign mass to light, because imagine you have a cavity. Imagine you have a box with hollow in it. If a photon is emitted from one side, it'll bump the box over. Okay. And then what that means is that if you only count the mass of the box, it means that the center of mass of the system actually changed. But if you assign mass to the light, then the center of mass of the system remains the same. So if it is important that you maintain, if it clarifies facts to make that generalization that the center of mass of any set of masses will not change, then you have to redefine mass. And I actually really didn't like this at first, but then he gave me this argument, and I said, oh yeah, that might be a legitimate reason to redefine what you mean by mass. I don't know if it is, but it's a good argument.
I think the more consistently applied these terms can be for the more situations, then the more useful it is as a grounding concept.
You need to achieve 100% consistency.
That would be ideal.
It's very difficult. Yeah. It's very hard though. Yeah. It takes years, but my book actually has a systematic way to do it. Yeah. So
my particular intuition about that is that many of the so-called constants of nature are actually material-specific properties, and that we can rescue the universality of some of these broader concepts by recognizing the context-specific behavior of the way that something like temperature scales in a system. It's actually more context-specific than people want to acknowledge.
And for example, you're talking about a Boltzmann constant that's specific for any given material.
Yeah, and it might be the same for many of the other constants as well, unfortunately. But I just have this intuition that's we oftentimes, Hooke did this, put a constant in for his spring, right? And it's a very convenient and nice thing to do. And anybody who's worked in some academic system in physics has probably messed around with an alpha parameter in their system. And we have these constants that they really kind of solve the problem for us temporarily. And sometimes they become very popular. The speed of light is one that's extremely popular. It is certainly possible to stick it in there and carry on. But the same with Boltzmann's constant. And I just wonder if we don't have some surprises down the line when it comes to really making consistent variables in our equations remain consistent and applying to 100% of the cases, like you were just talking about. Mass, temperature. What are some other ones?
Conductance, impedance, density, like
Yeah.
permissivity. There's like a ton of physical properties that we have to deal with that it seems like every single physical force, mass, like it just seems like what you're saying, that every material property that has some kind of equation that uses it needs to have some basis for why that physical property why that constant looks the way that it does from the first principles of what it is actually describing. And if we can't figure that out, then we're sort of stuck with either accepting this.
Like if Planck wants to ignore the material properties that give him his equation, in other words, the black chamber that does it, then he destroys the concept of temperature for all of humanity. But if he wants to acknowledge that he used an idealized situation, then all he does is have to modify Boltzmann's thingy, and then we just have like refractive index or something. We just have like material-specific distributions of temperature within a body. So, I just think that in order to save some of these broader concepts, whether it's force or temperature or something like that, we might have to rethink some of the constants of nature, essentially.
That might be the case. Something I would emphasize, though, is that just because you don't have an explanation for why a given constant is the way that it is, it doesn't invalidate the claims. When Hooke said, the stiffness is just K, like that really means something. But it's limited. There might be more to the story. But in this context, that really, to a certain level of accuracy, that really captures the stiffness of the spring. It really does. And you want to find an explanation for it. But just because you don't have an explanation doesn't mean it's wrong. It's right. And yeah.
I think that what I would say is that it is right, but that you should be able to come up with an explanation for why certain materials have a specific K.
What if he'd made K stay constant? He was like, K is always the same. And then you're like, well, but then I calculate different X's. And he's like, well, that's just the effective X. That's not really the length. That's just the effective length.
But that would be madness, because
that's
then
what they've done with temperature. That's all I'm saying.
Oh, I see.
Yeah.
Well, so, but I'll identify.
It is madness.
Okay, right. This is a reductio you're doing. So, why specifically is it madness? It's because you'd have to have a special set of ways of measuring distance that work for springs that's completely different from the way you'd measure distance in every other context.
Yeah. Well, it would be like Hooke.
You're not going to change that. You're going to change K.
Yeah, because Hooke did his experiment on this one spring, and the spring had a springiness to it, and he was like, that's the same for all materials. And he's like, kind of right. Like, there is a springiness, like, you know what I mean? Right? But he like, of course, people had the wherewithal at the time to realize that they should probably change the prefactor, and not the distance shouldn't be labeled as some effective distance,
Well, he probably tried multiple springs.
He
Well, and
probably
he.
did. I'm sure this was easily avoided. It could have easily been avoided with the black body work as well, but
Mhm.
it wasn't, because Planck wasn't an experimentalist and he couldn't care less about that. He just wanted to take the ideal and extend it to all of reality, because why not? That'd be really nice.
He had his pet theory and he was just
Yeah.
advocating for it.
Yeah, and if the temperatures are incorrect, well, that's just the temperature of the rays. It's not really the temperature of the body anyways, so it doesn't really matter. It's the effective temperature. I don't know. I imagine that this kind of thing is cropping up all over the place. And if we're going to try to rescue our physical understanding of the major variables in our physical theories, we might have to think a bit more about the context under which those variables were interrogated, which usually means going back to the history books and studying these
Yes.
experiments and studying these miserable 300-page proofs and seeing like how the hell does this go off the rails? Like what the heck happened here? Which is kind of where we started at the beginning of all of this. Most people don't have the time for that. And I think that's a real tragedy of perhaps the program of education that, as a humanity, we've gotten behind. Because, yeah, we're really good at being ready for the workforce, but we're not particularly great at innovating anymore.
At least not on the fundamental levels of science. Because we stand atop an enormous skyscraper of achievement before us, like that came before us. Like when we talk about Maxwell's equations, when we talk about general relativity, when we talk about all these things, it's the billionth floor of the skyscraper, and a bunch of the floors beneath us are just shrouded in clouds. We don't know how we built to this point. And so to understand the point we're at now, like the work is going to have to be done. This historical work is going to have to be done to go back to the observations and the reasoning steps that supposedly proved this stuff to begin with. And what we're going to find is that some of it was never really proven. Oh, here's a concrete example that I think you guys wanted to talk about. We can move on if you want. But when I looked at the evidence that the electron is a particle, here's the evidence that I've seen so far. I might be missing some of it because I maybe need to study the history better, but here's my understanding. The evidence is that the first bit of evidence was during an electrolysis reaction, charges are passed around in discrete units per mole. And so that lent itself to a natural hypothesis that the atoms were passing around individual charged particles. Then later, Thomson shoots these particles across a beam and he finds that they have a certain mass per charge. Then Millikan finds the discrete unit of charge by levitating a bunch of oil droplets, and he finds that each of them have some certain unit of charge. And so this is starting to look very convincing. Yeah, the atoms are passing around these little particles, and each particle has a certain mass and a certain amount of charge. Totally reasonable hypothesis, might be true, but it doesn't prove it, especially in light of the fact that there's another kind of phenomena that could account for this, which is the passing around of a wave. So is that the atom absorbs and emit it? It could be the fact that the electron is a wave, and these waves are absorbed and emitted in such a way that it will always have a certain amount of mass and it'll always have some certain amount of charge. And you can only have, and why is it that this wave can only be absorbed and emitted in certain ways? Because if you think about a musical instrument, that's the way it is. It can only vibrate at certain frequencies because of its structure. And so it can only accept or emit certain frequencies. And maybe that pans out in such a way as to produce discrete charge and discrete mass. And so this is an example where, it's proven it's a particle. But then you look back, are you sure it was proven? You have to go back and look. And I think there's a billion of these little nuggets lying around. We've identified some of them when we start to question it. We start to come up with a new hypothesis based on that questioning. But there's probably a lot of golden nuggets that laying around in the history we have yet to uncover. So
yeah, resonance is quantized as well, and it's not magical, mystical, spooky weirdness. Like I can go in there right now and play a note on my guitar to make my snare drum on the other side of the room vibrate.
Yep.
I can also play an octave of that note and do the same thing. And like there's different harmonic structures I can get, and it has to just do with the tightness, the tension, and the drum, the dimensions of it. So yeah, if your ultimate readout for electricity is the atom changing its harmonic states, well, it doesn't have to be magic particle stuff to have discrete changes in the vibrational states of an object. This is pretty well played out in the ordinary macro scale world.
I also want to add that there's something really fascinating about J.J. Thomson's story, because he was really preoccupied with the fact that when you read his papers from maybe like 1897 to 1905 or so right around the cathode ray experiments where he's getting really popular, he's basically like, I have demonstrated unequivocally that these cannot be etheric rays. I have demonstrated that they are electrons. And so he shows some supporting evidence for why it's the case. And basically, his evidence is the fact that he can deflect it with magnets, but etheric rays can't be deflected with magnets, because they hadn't shown that light outside of a medium could be moved or changed with magnets. Like Faraday had shown that you can change the polarization of light as it passed through leaded glass or like, I think maybe water or oil, but you couldn't take a magnet and deflect light. And so he's like, if I can deflect this ray, it cannot be a ray of ether, because the ether is not deflectable with magnets, but I can deflect it. Ergo, it cannot be ether.
But they had a more limited concept of the ether back then. They thought the ether was only electromagnetic. It wasn't on their radar yet that matter might be a wave of the ether.
Exactly. And so, but Thomson at some point, and so what's really fascinating is that you have this period of time where Thomson is writing this stuff about the cathode rays being little negative electron particles. And then he kind of disappears from the record. He gets a Nobel Prize for this stuff. His work is almost unavailable on the internet. And I found a paper of his from like, he died way late. He died like almost in the 40s. And I found a paper of his from the late 30s where he's actually like, what the fuck is mass? Like, where is this stuff coming from? Like, what gives the electrons their mass? And he's like, it has to be vortices in the ether. He's like, I cannot process it or prosecute it in any way except for treating it as this fluid dynamic interaction with a substance. And so I think that what's happened is that it's exactly as you say, the history of these ideas and the way that people were proponents of them or proselytizers for them have been eroded in favor of constructing a very convenient narrative, which is like J.J. Thomson proves that these are negative electron particles that are being shot out from the cathode. But then if you actually look at how J.J. Thomson interprets his own work over the course of his life, it's the fact that he goes from, there's no way that this is ether, to, I think there's no way to explain it without depending on the ether. And that's gone. Like I had to dig and dig and dig to find it. And because all of his papers are at like Trinity, like in the basement. They're not digitized, they're not published, they're not like easily available on the internet. It's crazy. And there's so much of that that's just hidden in the archives, where the very same people that came up with the experiments that we're pointing to eventually came to interpret their results in radically different ways than what we think they said. I can tell that Shiloh is at his limit. Are you at your limit?
I mean, yeah, my brain's pretty full. I think that we should maybe cook some dinner, and we should follow up on this. I'm really excited to share our full thoughts on this once we get our book out, which will hopefully be by the end of the year.
Oh, really? So very soon. Wow.
Shiloh's going to murder me if I can't finish it.
That. Yeah, it makes me feel better.
Yeah.
I mean, by the end of it, that's just like a couple months.
Yeah, I was hoping by the end of the summer. That didn't happen. But yeah, we're super excited. We just hired an illustrator to bring some form to our ideas. And it's just, I think it'll be fun. Both the first half is in some sense a philosophical treatment of the history and as we see it, where some things went off the rails. And the second half is a hypothetical solution set, which is in some sense just icing on the cake of what we've been talking about so far, but our particular structural attempt. So
and not just your structural attempt or hypotheses, but also like fundamental methods of how to conceptualize these phenomena in terms of what I call broad physical categories like entity, property, relationship.
I think the first half of the book deals with a lot of that philosophical substructure. I
Yeah.
honestly think that it doesn't really matter what terms you use and stuff as long as you're clear about it. Like if I can read your book and you lay out what these terms mean to you, then I can get a lot from you. Even if I would maybe define it differently or do something, that's fine. It just needs, you
need to be open to a different structure of thinking, and then even if you don't use the words that same way, you still learn that you like, okay, he uses the words like this. What is he referring to reality? Okay, fine. Like he's referring to something real. Like let's follow him on this. Yeah, it's very important. A lot of people flip out when you use the word the wrong way. And it doesn't make any sense because you might need to change the way the word is used. Even if I'm not using the clearest word, still pointing to reality, you can still make connections from that. I mean, that being said, I do think I've framed my words clearly.
Well, yeah. I mean, I think that's. I would hope that anybody who went to the length of writing a book would at least be internally self-consistent by the time you. Because writing a book's a lot of work. I mean, my God, how many?
I mean, it was. I mean, it was years of making it a consistent system.
Right.
Well, and I mean, not only that, but there's a whole different part of the book called cross-conceptualization where I talk about the process by which I formed the consistent system. Like it's like, how do you see each concept in the light of each other concept? It's a process I call cross-conceptualization.
Cool.
And I actually show like, well, here's how I arrived at this set. It wasn't just like, oh, I felt like using these words. Like, no, I found that if you don't use them this way, you run into all kinds of contradictions and you can't capture all of the facts that are involved.
I love that.
So
that's awesome. Yeah. Heck yeah. And then, the second half of this book we're doing is just trying to give form to the equations. That's it. Which is, I think,
a
kind of
physical understanding of each, like Maxwell's equations and and Schrodinger's equation.
Yeah, I mean, I think we obviously can't cover everything. It's not the last book we're going to write about this, but the whole goal of the project is to give physical form to. It's really what we've been all talking about for the last half hour, 45 minutes. It's trying to give physical meaning to the equations that seem terminally abstract, and it's really not even so much that we're certain we're right about these things as much as we want to, although like you, we are quite pleased with the solutions we've come up with, which I think is perfectly healthy. But it's more just that we believe it can be done. We believe that physical form can be given to these equations.
You're at least paving the way and showing like this is the kind of thing we need to do. Even if there's flaws in it, this is doing something right.
Yeah.
And you can learn from the process, even if the outcome wasn't perfect.
Yeah. I think the atomists 2,500 years ago had some really good ideas. Yeah. They're wrong about a lot of stuff, but that doesn't undermine the value of what they gave us too.
Yeah.
And so that's kind of the road we're on. I think we're all on that road. So
yeah.
It's cool. I'm really pleased that you came out here, man. It's cool.
Well, I'm psyched we're on that road together.
Hell yeah. But yeah, before we sign off, you want to just remind people one more time where they can find your work, your books, your YouTube channel, all that stuff?
Yeah, so my YouTube channel's Inductica, and if you go on patreon.com/Inductica, that's how you can support the channel, and then that's how you get a copy of the book. So I appreciate you guys having me on.
It was a blast. I really enjoy talking to people where we don't have to start at the beginning of, what's a field, what's a force.
Right.
And we can get deep into it.
Yeah.
So it's really good.
Maybe next, I hope we do this again and we can pick up now that we've gotten, what would you say, knee deep, ankle deep?
Ankle deep, I would say. Yeah.
Eyeball deep. Yeah.
All right. Yeah. Let's cook some food.
Very good.
All right, bye everybody.